All right. Hey guys. So now we're going to hit discovering atomic structure. And this is the stuff you're probably a little more familiar with, okay? Or at least some of the names, maybe a few of them. So the first guy that really did some work in atomic structure is Ben Franklin. Okay, so look, actually, let's start with this. Let's go back to Dalton for a second. After Dalton in 1803, all right, the atomic structure, the idea of what an atom was, is like this. So let's see, Dalton. The idea of the atom is sort of like this just round, uh, indivisible ball. It's like solid. Okay, solid, round sphere all the way through. That couldn't be broken up. All right, so that's where we are now at this point. Then Ben Franklin comes in and he discovers electrical charges, that there are positive and negative charges that exist in the world. And he found some information about them, that opposite charges attract and like charges repel. So if you think about magnets, or if you think about anything like that, where the same charges push away from each other and the opposite charges will attract. Okay, so that's the first sort of information that was found about matter in general, that there are these charges and this is how they work. We still don't know necessarily that there's anything else to an atom, but this is information that we start with. So along comes a guy named J.J. Thomson. He studies cathode ray tubes. Okay, and cathode ray tubes, probably not familiar with this, but cathode ray tubes look like this. Okay, it's like a glass tube part, and that actually shoots beams through it. It shoots cathode rays. Okay, and a cathode ray tube actually is one of the first pieces of equipment that led to TVs. So early TVs actually had these huge cathode ray tubes in them, and that's how they projected the images on the screen. So this work actually, not only did it lead to information from about the atom, but it actually led to the development of something that is all over in our everyday lives. Okay. All right. So that's a cathode ray tube. So when he shot the, actually, let me go back to that. So what happened is when he shot the charge through the cathode ray tube, okay, what he found is that this stream of material, he didn't know what they were, what he found is when they went through, they actually were deflected. The ray actually bent. And it bent because he had charged plates here at this part, and as the beam shot through it, it got deflected. What this showed him is that the beam of particles that he was shooting, excuse me, were negatively charged. So J.J. Thomson actually discovered electrons. Okay, so after Thomson, our atomic model actually turns into something kind of like this. I'm going to draw it a little bigger here. okay, where you've got positively charged mass. Okay, but in that positively charged mass, you have electrons, discrete, which means actual physical electrons floating around inside this positively charged mass. Okay, this is called the plum pudding, which is something that only old people know. Or for you guys, the chocolate chip cookie model. Okay, so Dalton's model was just a solid sphere. After Thomson discovered electrons, right? That leads to the model of the atom changing. We know there's different parts to it. So they thought it was all solid mass, and then there were these negatively charged parts. Okay, so moving on from there, a guy named Robert Millikan did experiments that allowed him to measure electrical charge and calculate the mass of an electron. So just did more experiments with electrons, find out more information about it. Then a guy named Ernest Rutherford did something called the gold foil experiment. Okay, so I'm going to bring that up here. All right. So Rutherford's gold foil experiment is where he shot a beam of particles at a really, really thin layer of gold foil. So they thought that this beam of particles was really big compared to the gold foil. So to get an image, it would be like shooting a bullet at a piece of Kleenex tissue paper or tissue paper. So they thought that the beam of particles would just like punch right through the gold foil and like just go straight through it. But what they found was as the beam tried to go through the gold foil, some of it went through, but some of them got deflected. Okay, here's a little better picture. Some of them bounced out and got deflected. So it was really, think about that. Imagine if you fired a gun at a tissue paper and the bullet like bounced off, or even if the bullet like went through but it went off to the side. That'd be like crazy weird. Right? So they were super confused. And what they ended up finding was this. Let me see if I can get the image bigger. There we go. What they realized is that the beam that was going in, some of them bounced back, some of them got deflected. And what they realized is that the beam was hitting something in the gold foil. So if the idea of the atom was like they thought with Thomson, it would have just punched right through because the mass would have been spread throughout this whole area. So it would have been like really, really thin. But what they realized with Rutherford is it proved that the atom is mainly empty space, but it has a dense, small center. So Rutherford actually discovered the nucleus. Okay, what does that give us? Well, that gives us a different version of this. So Rutherford, a different version of the atom. All right, so Rutherford discovered nucleus. Rutherford's version of the atom is going to be like this, which is a small positively charged nucleus with electrons orbiting around the nucleus. Okay, and this is what we typically, like if you look up like an atomic, not really an atomic model, but if you look up like symbols of atoms or clip art of atoms, like you see something like this. A small positively charged nucleus. Okay, so this is that's the nucleus. So the whole atom is this whole thing. So this is Rutherford's model of the atom after they discovered the nucleus, and the rest is all empty space with the electrons orbiting around. Okay. Now, just so you guys know, we're not going to talk about it in this, but there is one more, the current model of the atom to go. The current model of the atom is what's called the quantum mechanical model. And this is the current model of the atom. We'll talk about that in a different unit or whatever. Okay, so this is the development of atomic structure and how our understanding of the atom changed throughout the years. All right, that's it.